Hello students, we'll be discussing diversification today. So in diversification, there are a couple of things that we need to understand. First thing that we need to understand is the portfolio as it is. So let's assume if you have an investment in stock A and you're investing 100% in stock A. Ideally, if you try to diversify your portfolio, that is you add one more stock in your total investment. That is, now I'm going to invest only 50% in stock A and 50% in stock B. That means you have diversified your portfolio from a single stock to a multi-stock portfolio. Now, the combination of all your investments in the stock market comprise your portfolio as such. So the first question is, how do I understand what is the risk in my portfolio? So the first thing that we need to commonly understand is there is something known as we've discussed before, diversification. So diversification means you're going to invest in more than one stocks. So to ensure that the amount that you're investing somewhere stays safe. Okay, this is how it becomes safe is, for example, if I'm investing only in stock A and if stock A falls down, what happens is your entire investment falls down. So what you're doing is you're investing in something known as stock B also. So if it is 50-50, even if something happens to stock A, you're still safe with a certain amount with stock B. Okay. So in this specific case, what they'll tell is you can invest up to a maximum of 15 stocks. Now this theory was given in simple diversification. Simple diversification means the maximum you can diversify without any simple logic. Like for example, if you're just saying I've taken 15 different stocks from 15 different sectors. So in that specific case, you can do a simple diversification by selecting 15 different stocks. And that is what you can do first. So that is your simple diversification comprising of 15 different stocks. So that is the first thing that you can do. And after that, if you want to do something special, for example, if I want to create a portfolio, you can use something known as a sharp single index model. Okay. But before that, we need to understand, for example, I have a portfolio of 4 stocks. What is the risk associated with this stock? So this is one thing that I need to understand. What is the risk associated with my portfolio, which comprises of 4 different stocks? Okay. So in order to do that, what you generally do is there are several things that you can do. First thing, we need to understand how we can define risk in this case. So they'll always define risk in terms of standard deviation, or you can symbol this, or you can identify risk as something known as your normal variance. So variance in this case is just the square of your standard deviation. Okay. So in this context, what you can say is the total portfolio comprising, for example, you have 4 stocks, the total portfolio of 4 stocks and the risk associated with it, and the risk for, let's assume I'm giving a name of portfolio A. Okay, so I'm saying the risk from portfolio A is your so-called standard deviation of portfolio A. So how do you calculate this? So there is a specific method given by Markowitz, and I'll help you out with that method also. First, I'll show you this method on the screen here so that you can see the screen here. So this is the normal formula for diversification. This formula looks complex, but it is fairly simple and we can understand how this works. Okay, and I'll break this down, this entire formula, into a small thing so that you can understand how this formula is put and how it is conceived as such. Okay, so I'm going to write it here and let's see if we can understand this. Okay, so the formula starts like this. For example, there are 2 stocks. Okay, there are 2 stocks, A and B, and you decide to club both A and B in a single portfolio. That means your portfolio in this case is portfolio AB. So how do you identify the total risk from portfolio AB? So as I said before, total risk in this case is being signified or used using or understood using standard deviation. So this is like this. So I'm going to start the formula. That is your proportion of investment in stock A. Proportion of investment in stock A means, for example, if I have 100%, 1 lakh rupees, that is my 100%. So I'm going to invest somewhere around 50% in stock A. So that is your proportion of investment in stock A square. Your second one is your variance of stock A plus proportion of investment in stock B, the whole square, into variance of stock B plus 2 XA XB into R, that is correlation coefficient between stock A, stock B, standard deviation of A, standard deviation of stock B. This entire thing, if you put in a square root, will give you, this entire thing in your square root will give you standard deviation of stock AB. Now this is basically, if you look at it, is an expansion of an older formula that we've already studied, which is in this case, which is your A plus B, the whole square is equal to A square plus B square plus 2AB. So this is very similar to this. You can see this here. This portion is your A square in this case. This is your B square, and this entire portion is your 2AB. So this is how this formula is put, and this is how we can identify if the entire what the entire risk would be for portfolio AB. Now let's assume if there are 3 different stocks in my portfolio and I need to identify for 3 different stocks. Now for that, the formula is a bit complex, but we'll try to do it together. Now I'm assuming the 3 stocks to be A, B and C, and in this case my portfolio would be portfolio A, B and C. Okay. Now in order to identify my risk from portfolio A, B, C, I'll have to put this entire thing A, B and C into a single formula. I'm going to plug it here, and A, B, C in a single formula. That is what I'm going to do. So it is your proportion of investment in stock A the whole square into standard deviation of A the whole square plus proportion of investment B the whole square into standard deviation of B the whole square plus proportion of investment in C the whole square into standard deviation of C the whole square, and plus, I'm going to do it again. The first thing would be like this, that is 2XA XB, 2XB XB into RAB, standard deviation of A, standard deviation of B. This is the first part of the formula. Then you will move on to the next thing. Now this is the relationship between A and B. Next would be relationship between B and C, which is 2 XB XC into R BC, standard deviation of B, standard deviation of C. And now the final relationship between P and that is A and C. So you'll start off with 2 XA XC into R AC, standard deviation of A, standard deviation of C. Now you plug this entire thing into a single formula, and you will arrive at your individual, that is your the portfolio risk and your individual risk also. So this is how you can do, because this is a very complex formula. So what they have done is they have given us a smaller formula to work with using a matrix method. Now you can use the same data and plug it into a matrix that you can work accordingly. I'll help you out with the matrix also. So in matrix, what you tend to do is you calculate the variance of the portfolio. So what you will do is you will do n I equal to 1 summation n I equal to j, okay, xi the whole square, okay, xj the whole square. These are the 2 stocks that we have, I and j. R I j, correlation coefficient between I and j. Then you will have the next one, which is again this case, which is your standard deviation of I, standard deviation of j. So you can do the same exercise here also. You can understand how the proportions are done, and you can do this here. This is done in a different formula also. I'll show you this formula here so that you can see the same formula here. This is it. They have skipped squares for it. If you want, you can skip squares also in this case and do this exercise in a similar manner. I'm going to rub it here so that we understand this better. If you do not want squares, you can leave that also. That is also something we can do, and this will give you matrix method. So this is how this entire exercise is done. Thank you so much. Thank you.